Hello, class. I'm here to teach you about ions. But first, something is going to start showing up on your papers. And when I forget, you're going to remember. It's the idea of cation affirmations. And we're going to learn why your teacher's dressed like a cat and what a cation is. But the word affirmation just means to make a really awesome statement. Like, there is no limit to what you can do. Or, you know what? It's a good hair day. Or my cat loves me at 2 o'clock in the morning. Always wants to tell me. It's really wonderful. All right, so let's learn what are cations and anions. To do that, we have to first start with something called the octet rule. And to start with the octet rule, I see it clear, and I don't know if you see it clear. Before we talk about the octet rule, we have to do a reminder about valence electrons. So, hopefully you have your periodic table in front of you, and if you don't, go stop me and go get one. But what are valence electrons? Well, hopefully you've all answered that valence electrons are the outer shell. And we did something, and what that has to do with the octet rule is the octet rule is about 8. And that everything wants 8 valence electrons. Because 8 valence electrons makes it a stable atom, a stable molecule. I always talk about it that it's now in nirvana. It's happy. It's just hanging out there. It's no longer reacting. So to get to there, they're going to gain or lose or share their electrons. Now, going back a couple lectures, my good friend Captain America was here. He told you the atomic number. He taught you about atomic number, and that was the protons. And we've been using it to say that was the protons and the electrons. But the electrons, as mentioned, can change. But the element is determined by the protons. So we're now going to start changing the electrons. The electrons determine chemical reactivity. And the octet rule is 8 valence electrons. In your periodic table, or actually if you have the notes, I put a periodic table at the bottom of those notes for a reason. And that is, we did the valence electrons as the electrons after the noble gas core. So these are the ones that react. Valence electrons are reactive, and they determine an element's chemical reactivity. I don't think I'm ever going to get used to talking to a computer instead of real people. That's why I get these weird awkwardness, and you guys don't know because you didn't know me before this whole pretend world we live in. All right, so we're going to talk about it with that periodic table that's at the bottom of that page of notes, because it allows me to do a trick that makes this lesson really easy. It's like, what's up the cats? Isn't there a cat trick or something? And that is the periodic table. Wow. They used the number in a different way. Like right now, most of you have the periodic table where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it's 13, 14, 15, 16, 17, 18, right? It's just numbers that's straight across the families. Well, there's another way that it used to be numbered, which made a lot more sense. And that numbering way, we're going to turn on the light just for the heck of it, was that this was 1A and this was 2A. That's still the same, but where it changed was over here. Instead of 13 through 18, they were called the 3As, the 4As, etc., etc., etc. 5A, 6A, 7A, and 8A. And what that meant is the A number equaled the valence electrons. It was an old way of defining valence electrons. We've changed it to everything after the noble gases, but the valence electrons were your S's plus your P electrons. That's where the 8 comes from. They're the ones that are important. We'll talk about these in the middle very soon. But it's how many electrons you need to gain or lose to become like a noble gas. And so they used to number the periodic table like that. And the A group just told you. So if we're talking about phosphorus, which is over here, P, now it's under 15. But its valence electrons were actually, right, because it ended as 3s2, 3p3, we would show neon. And it would be 5. The 15 actually was how many total it had. So phosphorus has 5 valence electrons. And everything else in its family also 5 valence electrons. So to become like a noble gas, it has to move 3 spaces over to get to 8 or 18. It doesn't matter which way you do it. So it's going to gain 3 electrons. So what this lesson is about is you have to, by the end of this lesson, well, not necessarily by the end of the lesson, by the end of the study set, when we go over the study set, feel comfortable that you can predict charges of the elements. The ones that we're going to be predicting charges of are the ones that were historically called the A group elements. They were called the main group elements. The ones here in the middle, you've heard me call it that before. They're called the transition elements. They're in the D block, and they're going to do something really funky. And so they're numbered. If you look at that periodic table at the bottom of the page, the B numbers did not go 1 through 10. They actually are numbered funky because of how they behaved. Everything was based on behavior, and then they just went more systematic and numbered 1 through 18. It doesn't matter to me what periodic table you use. What matters to me is you have an understanding of where these numbers are going to come from. Because it is something that's important. So if someday you're sitting in a class, say a nutrition class, and the teacher, oh wait, they don't do that in nutrition, but let's say you're in an anatomy class, and they write a symbol on the board, and they write Ca plus 2, that you're not sitting there going, what's the Ca? Hopefully you all know Ca is calcium. And the plus 2, you're like, oh, that's just the charge of it. And you're not going, where'd they get that from? You're like, the person next to you is saying that, but you're like, oh, this is where they come from. And you can explain it from the periodic table. And so it is. It's really cool to understand the whys behind it. And it actually will make you be able to do the next steps that we lead into over the next 2 months. All right, so let's get into predicting charges. The key with the octet rule, it was named the octet rule because of 8 valence electrons. They've adapted it now because of how valence electrons are counted. It's more that you gain, lose, or share electrons to become like a noble gas. We're going to, in this video, talk about gaining and losing electrons. I know there was something else I was going to talk about because I wrote it on that page. But we can have cations and anions. So let's talk about those first. Alright, so there's cations and there's anions. Yeah, tell you what, this collar, it's like choking me. My poor cat. I do that to him, huh? Right. You can trust your teacher doesn't have fleas, and I'm not going to get lost, so we won't worry about the collar. Cations. This is something a student said to me 22 years ago. And I looked at him like, you're crazy. But the way you could tell these apart, cations are going to have positive charge and anions are going to have a negative charge. And so he told me the way he remembered this was cats have paws. So they're positive. And I looked at him like, okay. And now they've even taken it a step further. This is all over on Google now that cats have paws, so they're positive. So you can draw your little cat face each time. So cats, right, they're positive. And anions, it's actually how they say it everywhere else in the world. I had a student from Britain one time and he said anions, and I looked at him and I was like, that's so cool. And then I realized we're the ones who say it funny. Sounds like an onion. And so onions make you cry, which actually can be a good thing. Crying's very medicinal. But they have a negative charge. So how do you get a positive or a negative? We're working with electrons. So when you gain an electron, you become negative because you're gaining a negative particle. This drives some students crazy initially, but then you get used to it. Cats, positive, because cats have paws, they lose electrons. So when you subtract a negative, that double negative makes it a positive, like a cat. We all have paws. I didn't have time to make my paws today. I was busy writing tests. All right. So there is a way to know from just looking at the periodic table. So remember I keep saying, each class you should look at the periodic table with new wonder because there's so much to it. So we're going to walk through different elements and see how we predict it. And this is going to be a little tedious how I initially teach it because I'm trying to show you how you get there. And then you just know from looking. Just like hopefully now you can just look at calcium and say, oh, well, it has 20 protons and all that kind of good stuff. All right, so let's look at sodium. Na is sodium. And if I asked you to tell me the protons, we're not going to worry about the electrons. You would tell, I'm sorry, we're not going to worry about the neutrons. It's all about the electrons. It has 11 protons. That is what makes it sodium. Now, if I ask you about the electrons, initially, you would say, yes, it has 11. That is not a stable number. The stable number is it wants to be like a noble gas. So, the nearest noble gas is neon. So to become like neon, it has to lose one electron. So it becomes 10 electrons. When you lose an electron, you show a positive. So we just say +1. In fact, all the 1A's are going to be a +1. All of them. It turns out that's what they have in common. Now, Mendeleev put them like that because they had similar chemical reactivity. Now, if we go right next door to magnesium, magnesium has 12 protons. That doesn't change. If it changes, it's a new element. It starts with 12 electrons, so I don't show any charge, but it wants to become like neon. So it's going to lose 2 electrons. Now it has 2 more protons than electrons, so we can show it, you can either show it as a +2 or a 2+. Technically it's shown as a 2+, and there are teachers who will mark you wrong if you write it how I did. But what I've learned is my purpose is to help you to understand this. So you can write as a +2 or a 2+. The question came up always with the 1. They never show the 1. But that doesn't mean you can't. If you want to show a +1, you can show the 1 there. It's for you. This is for you to understand it. Not to keep asking Google for answers, because it turns out Google doesn't know a lot of things, does it? All right, and this shirt, which this is a true story. I had a student named Kat, and she gave me this shirt, and so I love wearing it. It says, "I've lost an electron. Are you positive?" Ha 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 ha, right? even more ironic because Kat gave it to me. And Naomi, if you're watching this, that was your sister's lab partner. All right. So the 2A's are going to be +2. And we can keep doing this. And what we're going to find is that metals lose electrons. So this whole side of the periodic table, like 80% of the periodic table, form cations. Isn't that wonderful? You're going to be positive. Right, the 1A's are going to be +1, the 2A's are going to be +2. That whole D block, let's ignore it for right now. We'll get to it. So, if the metals form the cations, who is going to form the anions? And I can hear somebody saying non-metals. All right, so remember that little zigzag on the periodic table. If you're on this side, you're the non-metals, which means you're going to have a negative. You're going to become an anion. And if you're on this side of the staircase, and the ones that touch were metalloids, and they do some really cool stuff, like they usually share. In our class, if they're below the staircase, we're going to make them cations, and if they're above the staircase, we're going to make them anions. If you become so inspired by being a cat, because you want to dress up like a cat too and decide to take a lot more chemistry classes, when you take those upper level 400 or 500 classes, you're going to refine what happens to these guys. And it really depends on what they're reacting with. For now, we're just going to call metals and non-metals. And when we run into examples, you can ask. That's why I have office hours. All right. So the non-metals are going to gain electrons. So we have, let's look at F. Has 9 protons. F is for fluorine, not Fl. That's a new element. It's down the bottom periodic table. Not there. It normally has 9 electrons, and that makes it extremely reactive because it's not like neon. Neon's right next door, so it wants to get all these elements. The 1A's, the first family, and then the halogens. These guys are the most reactive things on that periodic table because they're so close to being like a noble gas. Remember, the periodic table is not flat, so sodium and fluorine are right next door to neon. So it gains an electron, and so it's at 10. We put a -1. All right. What's next door to fluorine? Oxygen. 8. Is not the octet rule. Oxygen is what drives our life because it's so miserable as oxygen. It wants to be in a compound. It wants to gain 2 electrons so that electrons, the outer part, is full. Its S's and P's are complete. There's no empty spaces. And so you show it as -2, or if you want, I'll show it correctly, 2 negative. All right. So all of oxygen's family, oxygen, sulfur, selenium, tellurium, they are all going to form -2s. Next door, when we get to nitrogen, without going through all this, nitrogen, phosphorus, they're going to form -3s. And again, you can show the sign after or before, but you always show the sign. And if it's more than 1, you always show the number. So you can't just say for magnesium 2. That will be marked wrong. You have to show +2. And there's an even older way. Like when this cat, first a kitten, we would write it as a ++. The thing is they've now found ones that have a +8. We're not going to get there today. That would be a lot of pluses. So it's not that they made it easier for you all. It's that, let's just believe they made it easier for y'all. All right. There we go. Cats have paws. Metals are positive because they lose electrons. Non-metals are negative because they gain electrons. We'll make the light come out again. So now we're going to put it together into a compound. So what most students do is they just take their periodic table. So if you have the one at the bottom of that page, and above the 1A's, or above it says 1A or the 1 column, they just now write a +1. So everything in that column, that's why hydrogen is truly a non-metal. It forms a +1. We get to them at the end of the next video. On that chart, it shows the 2A's or the 2's. They're going to form a +2. We're going to skip the middle for now because they're going to do something funky. And then over here, it calls it the 3A's, the 4A's. Let's skip to the 7A's. The 8A's are perfect. And again, on some tables, they're called 17, 18. The 7A's are going to form a -1. The 6A's are going to form a -2. The 5A's are going to form a -3. Now, there's a but. And that is when they hit the staircase, the charge changes. So normally I ask this question. If we're talking about carbon, is carbon going to gain? Here's the question for you. Does it gain 4 electrons to become like neon? Or it could lose 4 electrons and it would become like helium. So it would drop back. They're both stable. And they're both far away. It's like right smack in the middle. We can say the same thing about silicon. Does silicon drop back to neon or does it move forward to argon? They're non-metals. So we're going to make them move forward. We can't cross this staircase in our class. It's going to be this nice roll, this nice wall. You can't cross that staircase. Turns out it's not quite true. And we as humans love to break every rule that there is. Not sure why, but in here we'll keep the rules. Again, I'm a cat today. I like nice, clear boundaries. You know, I can leap over fences. I just don't want to. All right. To tell you the truth, carbon and silicon, they prefer sharing electrons. So we're really not going to see them as ions. Let's just move on. So, what if you had magnesium chloride? Well, you would first write your ions and you would say, okay, well, you're going to, because there's going to be blanks for you to fill in. Magnesium's a +2. Chloride is a -1. So how do I get that again? From your handy dandy periodic table that you find magnesium, and it's in that second column, so it has to end up like neon. So it needs to lose its 2 electrons. The cations are always written first. We always go, the metal, again, is positive. We always show the metals first, and then the non-metal is shown second, and it is always the negative. So we always write cation to anion. So we first write our ions. I'm going to put the 1 in this teaching video, +2 and -1. When they combine, they must be overall neutral, the compound, meaning the plus must equal the negative. So we can't take away, magnesium can't just be a +1. That would move it to sodium. That's like even more miserable. So we need 2 chlorines. So the final compound is MgCl2. I write my Cl, the L cursive. You don't want to write a capital. That would be incorrect notation. The 2 means there's 2 chlorines. We never, ever, never show a subscript 1. That is something I would mark wrong. And also, in your final compound, you don't show the charges. You just show the ratio. So this is a ratio. In a crystal of magnesium chloride, there's actually a quadrillion magnesiums. But if there's a quadrillion magnesiums, how many chlorides are there? Well, there'd be 2 quadrillion. Whatever it is, this is always double that. All right, let's try another one. What about sodium nitrite? some students are like, these are weird names. That's because it's chemistry. That's why you're there on that side of the screen, and I'm having to dress like a cat. All right. You know what? Because Katie's going to say, where was the bonus in the video? Katie, if you show up at the next class dressed up like a cat, give you guys a bonus point. You could also dress up like an onion. Really like that. That would be fun. You have to go find an onion outfit. All right, sodium on your periodic table. Again, when we do the homework, do your best at the homework. We'll go through the study set, the SS. You find sodium, it's in the first column. The 1A's are always +1. And the ending of names, compounds, we're going to go through, but we're not there yet. So don't worry about the ending. Just go with it for right now. That means nitrogen. So we have N. We find it on our handy-dandy periodic table. So noble gases, no charge. Next family, the halogens are -1. The chalcogens, oxygens family, are -2. And the nitrogens family, they're always -3. So you can show the +1 because that does help some students. So for this to be neutral, for this to work out, our positive must equal our negative. So we're going to have a +1 and a -3, which means we need 3 sodiums for every 1 nitrogen. So what happens is some students are like, I got this, and they speed ahead. It turns out they didn't get it. So we're going to do a couple more, and then we're going to look at the middle, the periodic table, because they do some really funky stuff. All right. By the way, before I erase this, what we're doing, metal plus non-metal, this is, we are, losing and gaining electrons. So the metal is losing electrons. The non-metal is gaining electrons. These are called ionic compounds. This is an ionic bond. It is really a shame somebody called it that, but they didn't know better. It is not a bond. Ionic bonds. Ready? It's a big word. Get your money's worth. It is an electrostatic attraction. I need that person behind me who everything just shows up on the board. It's magical. All right. Electrostatic means positive and negative. Attraction means they're not stuck together. They are like holding hands. So you like somebody, you hold their hands until you find something more attractive. Then you say, oh, there's a chocolate bar. I'll see you later. And you go for the chocolate bar. For me, I'm a kitty cat, so it'd be a piece of salmon, right? Or a bed, because it's the middle of the day. It's a cat. If you see a bed, you're like, see you later. That is different from a covalent bond, which we will get to. But this is just an attraction. And because of that, the other key thing on here is it is a ratio. It is not an absolute. It is not 3 sodiums and 1 nitrogen. It is a ratio of 3 to 1. So again, if you have a zillion nitrogens, you'd have 3 zillions sodiums. Because you never just, right? One would just be, you'd have to be a gnome. It'd be a really small gnome to see that. All right. You guys got this? Let's do 2 more. All right, potassium bromide. By the way, for right now, I'm giving you a name. You're writing the ions. So write the ions, put it together. And hopefully I'm not in the glare. We'll just come over here for the next one. And then we'll do calcium. And phosphorus. So again, we call it phosphide, but it's calcium and phosphorus. So pause me, try it. Count to 5 because you guys didn't pause me. Okay. First, we're going to write our ions. Calcium. It needs to give up 2. So it's going to be a +2. So if you come to my office hours, again, it's the cat warning you. Don't say, I don't understand anything. Tell me what you do understand first. And then say, and often as you verbalize it, or maybe go back 30 seconds and try it again. Again, this is phosphorus. Phosphorus needs 3 electrons to become like a noble gas. So phosphorus, you can think of it as at number 15, and it wants to be like number 18. So the difference between 18 and 15 is 3. This side is negative. So 3 negative or -3. All right, potassium, special K, it gets a 1. First column, they have 1 extra electron, they get rid of it. Second column, 2 extra electrons, they get rid of it. So alkali metals are always +1, the earth metals are always +2. Halogen, bromine, is extremely reactive, but as bromide, the "ide" means it's reacted. We only see the "ide" ending once the reaction has happened. It's a halogen. Bromine was at 35. It becomes 36. So it gains. So you just write it there on the periodic table. You guys have it so easy. And the problem is you're not using your minds anymore. You're depending on Google. And I have to tell you, having done 2 hours of grading, 5 hours of grading over the weekend, I'm exasperated. Because Google is not giving you good answers. Your brain will give you much better answers. All right. If you want, you can show the ones. If the charges are the same but opposite, it's just a 1-to-1 ratio. KBR. That's it. Simple. We don't show the ones. All right, with this one, 2s and 3s. The lowest number they have in common is 6. So you have to have the +6 and the -6, so they're gaining and losing the same. Which means it's not how many more calciums do I need, it's how many calciums. I need 3 calciums to get a +6, because 2 times 3 is 6. And I would need 2 phosphoruses. And some of you are going, I know a better way. So do I. Study with your own brain. Turn off the computer and do it on a piece of paper. Okay, the other way, and it's a trick, and you'll hear me mention it, but understanding why the trick works, it's how you always get to 6. The 2 and the 3 always swap places. So some students, tutors love to show this trick. The 3 always goes to the one that was 2, and the 2 always goes to the 3. And if you like that trick, great. What most people see is when they see the 2, 3, they switch places. All right, let's look at the middle. So right now, I'm giving you names. Actually, sorry, we're going to do a different name. I need the squid hat. It has to do with iron. And oxygen. Turns out, you can combine them like this. You can combine them like this. They're found both ways. Actually, even inside of us. They're both iron oxide. So back when I was a little kitty cat, they were called ferrous oxide and ferric oxide. And you had to memorize which one was which. And then they realized there were others. And there are others. And so what they do is when you're in the D block, so the D block metals have variable charge. I hesitated because it's not just the D block. It's all the metals except the 1As and the 2As. So the 1As are +1, and we'll write this all out. Let's just do it right now. So your cations plus metals, right? Got the idea? The 1A's are plus 1. The 2A's are plus 2. And then all the others, oops, it's not all the others. Aluminum is plus 3. All the others have variable charges. This is taught in so many different ways by so many different people who are so smart and all over the place. Pray and go by your teacher. All right, because even the person who taught me, they've backtracked, and I don't know why. They won't give me a reason why. They said they just got tired of students being told the wrong thing on Google, so they just decided to like compromise and go with the wrong information on Google. So what happens when they have a variable charge is you use parentheses. And in the parentheses, which is going to go right here, so you say the metal, and the parentheses is going to have the charge. In Roman numerals, I don't know why. It's just how it's done. By the way, the lab that we're doing this week is 4 pages of naming. And what I learned this past week, if you just Google all the names, oh, you're not going to get a perfect score because it turns out Google is not as smart as we think it is. Anyway, you're going to use Roman numerals. And there's a way you can figure it out. And you always figure it out because from the anion, in this case, the oxygen. Oxygen is -2. So basically, we're going to go backwards to what we just did. Oxygen's -2. And this is a 1-to-1 ratio. The iron must be a +2. So we call this iron 2 oxide. It's not how many, it is the charge. So now, I'm going to write this one up here so I'm at my eye level. Fe2O3. Oxygen is still a -2. Now some of you are going, oh, it must be a 3. And that's great. You're really fast. This is -2 times 3 oxygens would give me a -6 overall. So I need a +6 overall. So the irons must be +3 because +3 times 2 would give me a +6. So again, the 2s and 3s, you kind of do this swapping thing. Some people love that trick. And some people, you just, if you do the lab sincerely with your own brain cells and your own pencil and pen or whatever, you will get this and you will see 2s and 3s and you'll just do them. So the name is iron 3 oxide. The 3 is the charge of the metal. Of each atom of the metal, not all of it added together, because again, this is just a ratio. So each iron in this compound has a 3 charge. So that used to be ferric oxide. So we're going to do another one. So what if I gave you a name? If I give you the name, it's really easy. So iron 5, that's a V, so the victory sign, 5 oxide. So 1, 2s, and 3s. 2 is the most common number because S's have 2 electrons and they want to lose those S's. They were extra. Remember the S's were further out? They were like the next level and then the D's go in a level. Well, it turns out being out that level, they want to get rid of them. It's lots of words. Do you need to know it? Probably not. This means the Roman numeral always goes with the metal. Because at this point, non-metals are always fixed. I say at this point because everything's changing every moment of every day. So we write the charge. So the key, the students who do the best at this and they just cruise, one, they like that there's very clear rules. This is not like the English language. The English language does not have rules. It has whatever anybody wanted to do. This has clear rules. It just takes practice. It's a whole language we're learning. And if you're not going to practice, you're not going to pick up the language. And we keep building on this. So please do the practice. Please come to office hours. And please ask questions thoughtfully. Tell me what you do know. All right. Oxygen is oxide, and it means it has a -2. We get that from the periodic table, which you hopefully already wrote on. Again, it's going to be going through the study set. The study set has umpteen number of questions that walk you through it to see if you get your best understanding. And by the time we go through that study set, this should click and it will make the lab start clicking. All right. So we have a 5 and a 2. We have to put together in a compound because those aren't the same. So some of you see that they're going to swap also, which they do. And that's great. You get 2 irons and 5 oxygens. And some of you are like, I don't get the swapping, and that's fine too. Lowest number that 5 and 2 have in common, why the swapping works, is a 10. So what we have to do is we have to make the charges equal but opposite. So to get a +10, we need 2 irons. To get a -10, we need 5 oxygens. So again, yes, they did swap. So I can look like a smart kitty. All right, and there's our final answer. There's no charge in our final answer. That is why on the first 2 pages of the lab, I make you write down your charges, your ions, and then put it together. And then you have to do it without that. But I might change the lab and make you show me all your charges, all your ions, so that we can see. So maybe that's what I'll do when I get done with this. All right, we're going to mix it up. Yeah, you're going to do some practice. And I suppose if you have a question, you can ask or you can rewind. Just getting cations. We'll make this chart again at the beginning of the next video. But I'm just going to give you names for right now. Actually, we're going to go both ways. Here, I'm giving you the names, and you're going to write the ions, first the ions, and then the compound. When you write the names, I don't know why I sometimes write capitals, and sometimes I don't. It means write that. Hopefully you're doing your own thing. Writing them down, trying them. Your teacher's trying to remember which one she wants to do. All right, pause me, write down the question, and try them. I'm going to answer. And I really don't want to do this again. Write your ions first. This 2 means the titanium has a +2 charge. Chloride is chlorine. It's a halogen. It has a -1. Let's go back and do this again and again after we go through it. So you put them together. The I has to be a little I when you write the symbols. And Cl2. I think I'm back in the glare. Can you see that? All right. Hopefully you can. Next one, barium is Ba. What? How do I know that? It's not in the first 36. So it doesn't have a Roman numeral. If it doesn't have a Roman numeral, it must be in the first 2 columns. And there it is, number 56. It's a +2. And then sulfur is now called sulfide because it has a charge. So Ba2, S-2. So we just write one of each. It's a ratio. Little a, that S needs to be the same side as B. When you write the symbols, I am a nitpicker. It's like what little cats do, right? All right. Manganese 4 oxide. If you can't see the board, just listen. Use your ears as you're writing. I'll turn the light on after the glare of my eyes. This 4 means 1 before 5. IV is 4. Oxide is oxygen. So, this is a mistake students make. They're like, I'm so smart. I just swap them. And I go, Mn2O4, don't write this down because I told you I'm making a mistake. Oh, where did you do that? So then I would ask, what's the mistake? It is a ratio. Maybe I didn't write this. I did write that it was a ratio. It is the lowest whole number ratio. It's like a fraction. It is a fraction. 2/4 can be reduced. So the other way to think of it is the common number these had was a charge of 4. You only need 1 Mn for every 2 oxygens. So if you're going to be one of those people who swaps, which is fine, if that's your thing, make sure you reduce. If you're going to figure out charges, for all of you, you don't show that number. All right, that glare is from the awesome sunshine that just came out. We'll see, down here. Questions on that part? Oh, you can't ask me. I'm going to have to erase lowest whole number ratio so I can fit. Now, if I give you symbols, we're going to segue into where you're going to write the compound name. Now, what these all have in common is we're doing ions. We have stepped beyond your study set. You watch this video, the first page of the lab, you should be able to do. So, V vanadium, vanadium. I say vanadium, you say vanadium. Vanadium, vanadium. You want to ask yourself, do I need a parentheses? And the answer is yes. If you're not in these first 2 columns, if you're in the middle, in that D block, you need a parentheses. Now, I like to finish my piece. We're going to end with "ide." And we now have to figure out the number. And we figure it out from the S. Sulfur is a -2. And I know that from the periodic table. It's right under oxygen, and oxygen is always -2. You write it up above that family. You'll see me do it when we go over the homework, the study set, whatever it's called. And some of you see the 2s and 3 swap, or -2 times 3 is -6. So it'll be a +6. This is going to be a +3. And that 3 goes in there. Depends how your brain thinks about this. We're focusing, unfocusing. CO is cobalt. And then chloride. The IDE is important in writing the names. We'll see there's other endings. right? CO, it's a halogen. It's right next door to argon, so it's just -1. This 2 means that the cobalt has to be a +2. So the cobalt's a +2, and then there's 2 Cl's, and each Cl is -1. That was given. I gave you the ratio. You're just telling me the cobalt has a 2. So it's called cobalt 2 chloride. When you write the names, capitalization doesn't matter. When you write the symbols, absolutely. I don't know why I'm writing capitals for the first name for the metals. It must be a formal dinner party that this cat's going to. All right, iron. Wow, that's not iron. Should have made that mistake. Dang it. Let's go with it. We'll see who catches it. Well, your teacher already caught it. For a change. I'm sure if there was another mistake, somebody will tell me. And then oxide. Now, common mistakes. Students make 2 mistakes on this one. They either go with this weird rule they decide on, that how many you have goes in there, and they put a 1, and the answer is not a 1, or they decide it's the group number that goes in there. And for PB, they go, oh, it's a 4, and it's not a 4. You have to figure it out. So my oxygen is a -2. I have 1 of each. That means PB, plumbum, is a +2. The ones that get the Roman numeral, the ones that do not, it's the first 2 columns. The first column, the alkali metals get a +1, and the earth metals get a +2, and the other metals can go all over the place. I will always tell you, I'll either give you the ratio and you figure it out, or I give you the name and you figure it out. So I'm going to stop there. Remember, cats have positive. What's your cation affirmation?